Good morning, class. Welcome back to the channel. Last time we were talking about circles whose center was at 0, 0. If you haven't seen that video yet, I'll go ahead and link it right now. So this video is going to kind of bring everything together, and then I'm going to do a bunch of example problems, and then we'll move on. So a couple of things about circles, okay? There is really only two pieces of information you need to know when it comes to graphing a circle. You need to know the center and the radius. Those are really the only two defining traits of a circle. How big is it and where is it? Last video we learned that the equation of a circle that has its center at 0, 0 is x squared plus y squared equals r squared, because it's essentially just a generalization of the Pythagorean theorem. I'll take a moment here so that you can pause the video and jot down some notes if you need to. Now, the second bit of review that we're going to be using in the upcoming problems involves the vertex form of a parabola. Now, I know that was a while ago, and I know you might be thinking, wait a second, why are we suddenly talking about parabolas? Stay with me, I promise it'll make sense. This was the vertex form of a parabola that I gave you in the classroom. Y equals a times x minus h squared plus k. At the time, I told you that you could do something that a bunch of you weren't quite understanding why you would want to. Watch carefully. By subtracting k from both sides, we create an alternate equivalent equation where both h and k are being subtracted. So going forward, we're going to use this alternate vertex form of a parabola because I want you to see how closely it lines up with the standard form of a circle. Let's take a closer look at this. Do you see the similarities? Do you see why I chose to use h and k? I want you to see that this is not totally new information that you're learning here. This is why I tend to recommend that you save your previous notes and homework and exams, because often the stuff that you learned in the past will make the stuff you're learning in the future much easier if you have an easy way to recall it. A lot of the things that you learned when we were talking about the vertex form of a parabola apply directly to the standard form of a circle, so you don't have to learn the same thing over and over again. You've already got this, and the similarities don't stop with just the shape of the equations. With the vertex form of a parabola, the vertex was hk. That's the whole reason why we put it into vertex form in the first place, was because it gave us a very simple visual way of determining the vertex. Well, with the standard form of the circle, the center of the circle is hk, same as the vertex of the parabola. That's because these two values, which I happen to call h and k, aren't exclusive to one form of equation. That x minus h and y minus k will do the same translation moving up and down, left and right, in any equation in the universe. And in fact, for those of you who enjoyed using point-slope form back when we were talking about lines, you'll see that it's again the same pattern. The main difference between a vertex and a circle, of course, is that a vertex has a scale factor, which stretches it in the vertical or horizontal direction, whereas a circle has a radius. Once again, I'm going to take a moment and let you pause the video and take down notes if you need to. This should all be review. Okay, well, now that we've got this standard form, and make sure you have it in your notes because I'm going to be moving away from this screen in a moment, let's take a look at some problems. Okay, this worksheet comes from Kuda Software's Infinite Geometry. I will put a link in the description to the PDF of this particular worksheet so that you can follow along if you like. Questions 1 and 2 and 3 and 4 say identify the center and radius of each and then sketch the graph. So we're going to go ahead and look at number 1. And I think you're going to find that once we see this, once we get the pattern down, these problems are going to go pretty quickly. So, number 1, we have x minus 1 squared plus y plus 3 squared equals 4. We need to know the center, and we need to know the radius. Now I'm going to take us through step by step this first problem, and then we'll sort of pick up the pace going forward, okay? So here underneath the problem, I have put down the standard form equation that we just talked about. And hopefully you can see that in this case, h equals 1, not negative 1, positive 1, right? Because this is x minus 1, x minus h, so h is positive 1. With that in mind, let's take a look at k. If y minus k is the same thing as y plus 3, well then that y plus 3 is actually y minus negative 3. We can all agree that that's the same thing as y plus 3, I hope. So if y minus negative 3 is the same as y minus k, then k must equal negative 3. This is where that weird opposite thing that I've had a hard time explaining the entire semester comes from. Now, looking at the right side, well, let's see. 4 is the same thing as 2 squared. So if 2 squared is the same thing as r squared, then r must equal 2. Now again, for the first problem, I will be very, very thorough. We know that the center of any circle in the universe is h, k. Well, in this case, h is 1, k is negative 3, so our center is 1, negative 3. And our radius is 2. So in order to sketch this graph, let's start by locating the center. 1, negative 3 is right here. And now, using my whiteboard, I think I can make a circle. And then I can move it around so that it's the right size and in the right place. So it's supposed to have a radius of 2. This isn't perfectly a circle, but that's okay. I wouldn't expect your sketch to be perfectly a circle either. So that's approximately right. That's probably a little bit too big. But again, so long as you can show that it's got the center is 1, negative 3, and the radius is right around 2, you're fine. You don't have to sketch it perfectly. And on Khan Academy, they of course give you the digital tools to graph it accurately without needing to draw at all. So once again, I'm going to give you a moment because the future problems are going to go much more quickly than this one. If you have any questions about what you just saw, put them in the comments and I will happily answer them. Trust me, I have nothing better to do with my time. All right, let's take a look at number 2. The equation for number 2 is x minus 2 squared plus y plus 1 squared equals 16. The center is 2, negative 1, and the radius is 4. I told you it would start going faster. There's the center. There's our circle. Again, more or less. Let's look at number 3. Number 3 says x minus 1 squared plus y plus 4 squared equals 9. Take a second, pause the video, see what you can do. I bet you can figure it out before I'm even done writing it. Remember that because of that x minus h, y minus k thing, the two values of the center are always the opposite you expect. And then don't forget to take the square root to get the radius. Center is at 1, negative 4. And there, approximately, is our circle. Radius of 1, 2, 3. Let's move on to number 4. X squared plus y minus 3 squared equals 14. Now there are two parts of this that'll make students panic. Don't panic. The first thing that students will often say here is, I don't know what to do when it only says x squared. But yes, you do. Take a breath, think it through. That is still x minus h squared. It's not deceiving you. That x squared is still x minus h squared. So, if you can't see the h, there's only one value that h can be. H is 0. And that makes sense because the equation of a circle centered at 0, 0, if you recall, was x squared plus y squared equals r squared. So please don't panic when you see something that's slightly different and assume that you don't know what you're doing. Give it some time, give it some thought, you'll work it out, I promise. So, back on task. The center of this circle is 0, 3. Don't forget that opposite thing. And the radius is, well, is the square root of 14. But I don't know off the top of my head how much the square root of 14 is. So let's find out.
Square root of 14 is approximately 3.742.
Thanks, Google. So the radius is about 3.74. So our circle might look something like that. So there's 4 example problems of how to take an equation and use it to find the center and the radius and to graph the equation. There are 2 Khan Academy assignments that this will help you out on, both of which, of course, will be linked in the down there part. This series on equations of circles is not over yet. I will absolutely be doing some more example problems over the next couple of days, including problems involving the expanded form of the equation. So those of you who are working on that particular Khan Academy, don't worry, help is on the way. Spoiler alert, it involves completing the square. I remember very well how much you all loved that. Anyway, that's the video for today. Thanks very much for watching, and I'll see you tomorrow.